What? You want to take the test when you get back from the spring break?
We're going to have some rain back now.
All right.
I mean, that's a good point, though. I don't mind.
Yeah, don't play basketball.
You'll take it Friday before you take it after spring break. Hey, that's a great idea. We should just come in on Friday.
No.
I'm okay with
Are you really?
That's the championship game.
We have play practice, don't we, on Friday?
I have
All
sleeping
right.
in. Jeez.
Okay, let's focus here.
Don't we have? Oh no, I.
Alright, this is fairly conceptual, but also it has the math aspect to it. Okay? If you haven't got to the point where you know what strong acids do, what weak acids do, and how to know what you would do when you have those situations, and the little subtleties of if it's got multiple Kas, all these things are important as we progress here. Okay? Now, you've heard me use the term salt, and you probably even heard me use the term salt in the correct nature. Salt is really what we use to define any ionic compound. So not just NaCl is classified as a salt. CaCl2 is, KCl, KBr, Ki. All of those ionic compounds are classified as salts.
Salt with a tendency to roast over time.
What was that?
Salt with a tendency to roast over time.
So, salts consisting of cations of strong bases and anions of strong acids have no effect on the hydrogen concentration when dissolved in water. Why?
Because it would be a weak acid or a weak base.
For example, this will completely dissociate in water because it's a salt or ionic, correct? Okay, K plus, Cl minus. Well, what would this react with?
HCl, which is
No.
it's becoming hydrogen.
What would it produce if it reacted with water? Is that going to happen?
No.
Why not?
It'd be forming a strong.
You'd be forming something that always is what? Dissociated. So what it's saying is, if I take a salt that is a conjugate of either a strong acid or a strong base, it will have no effect on the pH because it won't react. Because if it reacted, it would produce a strong thing, which we know it won't because strong things never are produced. They're always the opposite of that. Does that make sense? Fairly conceptual. Same thing here. This is going to react with water to produce KOH. What is that?
Another strong base.
Well, this was a strong acid,
Right.
and this is a... So that's why it's saying when salts consist of cations of strong bases, so here's your cation of a strong base, or anions of strong acids. This is the anion that comes from a strong acid. Okay, this would be NaOH, this would be HCl, strong base, strong acid. NaOH, strong base, HNO3, strong acid. KOH, strong base, HNO3, strong acid. So what it's saying is that when I dissolve guys that have either anions or cations, they're conjugates of something strong, they're not going to affect the pH at all. Because in order for them to affect the pH, they'd actually have to react with water to produce something that's strong, which won't happen. Does that idea conceptually make sense to you guys? Yes? Okay. So you can imagine then there are some situations where an ion will break up into something that is not a conjugate of something strong. Okay? Alright, so it says for any salt whose cation has neutral properties. Again, what I'm saying when I say neutral properties is an ion that will not react because it would produce something strong. NaOH, strong base, KOH, strong base. But whose anion is a conjugate base of a weak acid, you're going to find that it will be basic. every single time. Let me show you an example. What will happen if I dissolve this? Is this in your notes at all? I don't know what the next slide says, so. Okay, it's not. Okay, what will happen? This is a salt. I got a cation with an anion. So what are the two? What are the two ions going to be?
NaOH.
No, before it would react.
Oh, Na.
Na.
And C2H2.
Okay, the question you need to ask yourself is, will either of these react to form something strong?
NaOH.
Yes. So this is going to have no effect because it would produce NaOH. So that is the neutral guy. Cation is neutral. When the cation is neutral and the anion is not, okay, it says it's going to produce a basic solution. Let me show you why. Okay? This is a conjugate base of a weak acid. Okay? So can this react to produce a weak acid? Yeah. Very much can, because weak acids don't what? Dissociate very much, so it means they're likely to form. Okay? Well, when this is in solution, and it's a weak base, it's going to react with its most likely acid. Well, what is probably the most likely acid it's going to react with? Water. Okay? We know that this is a conjugate of a weak acid, which makes it a stronger base. It will react with water, and a base does what? And notice what it gives off. So now do you see why when you have a salt who has an ion that is a conjugate of something weak, or in this case, this specific example, it's a conjugate of a weak acid, you're going to get a basic solution because a conjugate of a weak acid is a stronger what? Base. Okay? Remember we said conjugates are always the opposite? Okay, if I have a strong acid, weak conjugate base. If I have a weak acid, stronger conjugate base. Okay? So, doing great. We won't get through this whole lesson, but we're making decent progress. Okay, so the difficult thing that they give us here is taking our time to identify what won't affect and what can affect. Okay? So we said calculate the pH when I put this salt in solution. Let's first identify what of that is going to be important when figuring out pH. NaF will break up into Na and F minus. The question is, are either of these neutral? This is going to be neutral because it would produce a strong base, so it won't happen. Okay, will this produce a strong acid? No, HF is a weak acid. Okay, but be very careful. Is this an acid or a base? It's a base. Notice what they gave us. Ka. How do we go about doing this base problem when they gave us Ka?
Isn't that a base too?
What?
NaOH?
Yeah, but this isn't even going to react, remember. This won't react because it would produce something strong. So this is just going to sit in solution as an ion and not do anything.
Because NaOH associates, so if it's in water, it's not going to form anything.
Okay? This will react because it will react to form something that doesn't dissociate very well. Make sense? Okay? So the reaction will be this with water, 2 to produce a weak acid which won't dissociate much, and hydroxide. Okay? However, the thing you've got, I mean, this is one of the more difficult lessons because you have to think a little bit more than maybe you would normally do. Because I'm not going to directly use this number. Why not? Because it's Ka, and I'm not doing a acid problem, I'm doing a base problem. But I do need it. Why do I need it?
Because you wouldn't have it, you wouldn't be able to do anything otherwise.
Yeah, I'm going to have to convert this to what? I need the base version. This is the weak acid, I'm using its conjugate, so I need to figure out what the Kb of that is by using this equation. Anybody get it yet? That look right?
How do you, can you tell some of the acid or base just by looking
Well, partly practice helps. Usually things that are negatively charged are more likely to act as a base, not always. Things that are positively charged are more likely to act as an acid, but again, not always. Okay? A lot of it comes to just practice. But if you look, it says Ka of this. Well, that if you can tell the relationship between this and this, you can know what this is going to act like, right? This is going to act like a base if they give us the conjugate, which has the hydrogen, which is going to make it the acid form. Okay, so you do have to kind of critically think. Practice and experience will make this become easier and easier as you do more.
HF is an acid?
HF is an acid. Yes.
What, you always know the base receives hydrogen, so if you think of that, which one is on hydrogen?
No, it's
So,
No, not at the
Making
time,
it
I'll say
resolve.
if you read that.
What?
It's on-
what's making it resolve?
This reaction.
So that.
Yeah, this is the base. Yep. This is the Kb for F minus. This is the Ka for HF, they're conjugates. That's why we could use the conjugate from HF to find the base Kb for this problem.
But then when you have, just refresh, when you do this, you have to keep something for OH, so you have to go from OH.
Yeah, you will have to do another, yeah, think about the ending too. Yes, there's a lot in here. I know you're probably thinking, well, this makes no sense. We're producing an acid. Well, yes, but in the process, we're getting a whole bunch of OH minus, and this is a weak acid, which isn't going to dissociate. That's why this equation lies far where?
right.
This is a relatively strong base, and then this is a relatively weak acid. So where is the equilibrium going to lie?
Oh, far right.
Far right, producing a lot of this. Okay? Now, we could set up the whole ice table, but everything's a 1-to-1 ratio, right? So, 1.4, here's our Kb. X squared over what? 0.3, because this salt completely dissociates to give us 0.3 of F minus.
Why is it sent to the negative?
Can I not do this right?
You have to the negative 4. KP,
No, it's not. Well, let 410.
Oh, let's go 4.
And that's KB.
What did I do now?
Last time you did it.
let's go 4.
Okay, your X is 2 times 10 to the negative 6, I think.
Yes.
Right? Now, We should do the 5% test, but let's just use common sense. X divided by initial concentration, that's going to give you a really small percent. Everybody see it?
Yeah.
Okay? Now, this X is what? Yes. But do I just take negative log of that?
No, that's the OH.
That's the OH. Okay, so you do not just take the negative log and call her good. If you take the negative log of that, you're going to get POH.
If you did 14 minus and block that.
Yes.
Or you just.
Okay, so negative log of that, pH is 14 minus whatever that is, and your negative log gives you 5.7. So then your pH is what? So no homework tonight. However, it would do you some good to read this section. This is heavily conceptual. And applying all the things we've progressively been getting towards